Welcome back to the shop, everyone. It has been quite some time since I talked about the JDs Garage CNC plasma cutter that I built, and that's mainly because I have just been using it. I think I do have some video of me cutting some stuff out that I haven't released that, if that's interesting to anybody, I could quickly release. But I'm going to talk about what I'm going to be working on the plasma cutter now, and that's upgrading from JDs Garage CNC plasma cutter V1 to V2. Now, it is a paid upgrade. It's $25 for the plans, just like the original plans were $25. But I have opted for the torch height controller option, and I'll tell you why I want this. You may not be able to see it, but on all the slats that I cut, there's a ton of rust. And then over here where I've done the majority of the cutting, there's a lot of slag, and the slats are no longer even. So what happens is, as my torch runs just along this rail, it's actually going up and down, and it's adjusting the height just based on the metal not being flat and the slats not being flat anymore. And the same thing on the, I think this is the y-axis, that's the x-axis. So with the torch height controller, in theory, what should happen is, as the torch is moving this way, as the metal is getting higher in relation to the torch, so this is exaggerated, but imagine the plate sitting like this and the torch is here, right? So it starts at this end, it's at a great height. As it's traveling this height, it's getting shorter and shorter and shorter and shorter until it actually contacts the plates. That's what we want to avoid, and that's what the torch height controller is going to help us do. The torch height controller does not help you get speeds, does not help you get better cuts, it does not improve the cut quality. It simply, its only function is to keep the torch height at what you have configured it to be. Now then, in my case, for the Prime Weld Cut 6DD, they recommend 1/16 of an inch off of the material. So I don't know where I was going with that, but anyways, that's what the torch height controller is for. So I'm going to go through and gonna wire it. The second reason why I'm upgrading to V2 is I found that in open build software, the newer versions of it no longer supports the Arduino. It's no longer an option in the drop-down menus, and maybe I'll quickly show you that on the computer real quick. But we'll be upgrading to this ESP32 board, and I'll go through all the wiring as I figure it all out and read the instructions. I briefly looked at the instructions before, and they weren't the greatest, but as I go through this, we can maybe look at that as well. The torch height controller also comes with this right here. I don't know exactly what it is, but there's 1, 2, and then on the other side, 3, 4. So we'll figure this all out together. So I'll try and get you a shot of what I mean, so you can see, hopefully, that right now the torch is off of the plate. If I move it over, the gap is actually increasing. It's kind of hard to see by just how much, but if I go the other way, you'll actually hear it start to contact right around here. Oh, there we go, it's already contacting. So that's what I mean when the metal is just not even, and that's why I want the torch height controller for this. Alrighty, so here we are in the open build software, and this is what controls the plasma cutter. So, x-axis, y, z, etc. And if we go into, where is it? Wizards and tools, we can go to firmware flashing tool, and we can see that on version 1037 of open builds, if I go black box 4x, I have the Arduino Uno Com 3, and I forgot exactly what it was, but it's like, the port, it's fine, the CNC laser, and that works just fine. Now, if I recall correctly, when I updated this, so if I go open builds, nope, Just opening up a browser. I'm just going to update this just to show you. I have the old version as well, so that's not a big deal. Okay, so we're back. And as you can kind of see, Open Builds has already updated itself, which is interesting. But if I come over here to Wizards and Tools and Firmware Flashing Tool, well, maybe it is going to work. Interesting. Okay, so I guess it will still work. I vaguely recall when I tried updating to a newer version, it wasn't going to work as I expected. It wasn't popping up, but maybe I was just doing something wrong. Yeah, seems to be working just fine, so maybe I'll just entirely cut this segment because I was wrong. Maybe I'll start this whole video over again because I was completely and totally wrong. No, I'm not going to start over again. I was wrong, and that's just part of life. Everything seems to be working, and it seems like I could flash this if I wanted to, so I'm not really going to stress too much about it, I guess. Yeah. Cool. Let's just get into doing the upgrades for this. So it was driving me nuts that I couldn't figure it out. So what it is an open build. When I came to Wizards and Tools, I went Firmware Flashing Tool. There used to be a black box 4X tab right here. Now, maybe that's only when the Arduino is actually plugged in. I don't know. But I saw that we were missing this tab, and I went, oh shit, I guess, you know, what the original instructions say to do is no longer supported. Well, I guess I better upgrade to V2. So maybe what I'll do is I'll quickly go grab the old Arduino, and I will just see if perhaps it needs to be connected for that option to show up. Be right back, 1 sec. Okay, so we got the old Arduino. Let's just plug this in and see what happens. Wizards and Tools, Firmware Flashing. Yeah, so the black box 4X is no longer here. And that's what it was. That's why I was like, oh shit, I guess this isn't supported. But, you know, perhaps as long as you do black box X32, I don't know. It's just this interface tab. So anyways, that's the reason why I wanted to upgrade, is because that box was missing here, and I just at the time did not go into open builds and try and figure out what it's supposed to be now and blah 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 blah. I just didn't care. I was like, ah, fuck it, I'll just upgrade. Alrighty, in order to start this upgrade, I need to get the control box out of here. And that means that I need to get all of these wires all the way unzip tied. I don't want to do that. I already have a connector here for the Z limit switch. So what I'm going to do is I will chop these for the two, well, there should be three. Oh yeah, there's the third motor there. So I will chop all three of these right here. And then what I'll do is I'll put a big old 12 unit or 12 connector right here, so I can just disconnect and have a 12 connector. And that way I'll only need to cut 3 zip ties, leave all of this the same, and then I can pull the whole control box out. Now, what I do need to do is I need to label which one is which. It doesn't really matter if I label it like entirely accurately. I could just label this A, B, B. That's all that matters, and that means I won't get the motors mixed up. So that's what I'm gonna do. I'm just gonna cut, throw some labels, and away we go. right, so in the box here, we have our old Arduino controller. That is going to be replaced with this ESP32 controller. We also need to figure out what this is for. I believe this is for the torch height controller. So it'll have to go in here somewhere. And then the torch height controller itself, either it'll have to go in here or on, maybe I'll just mount this to the top. This torch height controller does have a LCD screen on it, so I'm not entirely sure if I need to see this, but there's also this dial which is going to do something. So this will probably get mounted on top where I can actually easily see it. This might just go in the bottom, on the side, I don't know, probably just Velcro. And then yeah, this board will go in here somewhere. So this board is actually quite nice in that I can also, like, I can pull the pins out of here and I could just plug them straight into here. I don't need to like screw them down. So this is actually quite a nice little breadboard for the ESP32 board. But I'm thinking these wires probably aren't going to be long enough, so I am probably going to end up redoing all of the wires up into the driver modules. But I need to figure out the wiring on this, so I might go back to the computer and just kind of bring up the schematic and take a look at what's going on and what's got to go where. Alright, so trying to review the schematics, and this is actually really pissing me off because when I originally bought the plans, I remember going into JDs Garage, the instructions and stuff, and there was like an upgrading from V1 to V2 instruction, but going in here, I can't find that anymore. So going into the electronics and software, you know, it doesn't really give me anything. Yeah, so there, I know at one point there was an upgrading section, but it looks like that's no longer a thing. So that's fine. But now that I look at the supporting documents and I look at the schematics, I'm like, okay, great, schematics. Okay, other parts, what the hell is this? So e-stop, I don't care about that. You know, 5-volt power supply, I think this is probably, what's that for? Yeah, so for the second COM on input opto ISO bank, and now looking through this, like I can't find, there used to be just a full schematic of the entire thing. Can't find that anymore. They've made it so it's just like each one piece is shown, which I don't like this. I want to see the full schematic. But now apparently I need this opto isolator bank board, which I don't have because I didn't realize this was going to be a requirement to do this. But this is going out to min and max switches. So I guess this is if you have limit switches. I don't have limit switches. Yeah, so this is, I'm not sure what I'm gonna do here. Maybe I don't need the opto ISO bank. Maybe that's just optional for the limit switches. Yeah.
Z driver, pull Z driver, Y and Y, X driver, DC relay 2. Like, ooh. I really dislike the way they've done this. This is just frustrating. I'd like to see a full schematic. And it was there before. So it's only like every time I work on this, I just get so demotivated because there's just so much stuff that is just frustrating to me. Whatever, we're gonna fucking power through this, I guess. Okay. That was... Yeah, so this relay is to start the torch, but they have another relay going to the X driver for some reason. So this is P12 off of the controller. I guess I'll have to open up the controller schematic. Like, I don't know why they have X pull going through a relay, but pull Z driver and pull Y driver go directly into the driver. Like, really, did they just have an extra relay? Like, pull goes into number 2 relay, but pull up here just goes straight into the controller. Like, it doesn't, I don't understand why they have this relay between the controller and the driver for X. It just does not make any sense to me. I guess, how's this being controlled? W2, the 5-volt controller. W2. W2 5-volt controller, W4 ground controller. So is this connected to the controller, I guess? Yeah, so W2 relay to DC plus, and then W4 DC relay 2. So the controller's controlling 5-volt and ground. Okay, SP32 pin out. So that's just 5-volt, I guess. No, that's not ESP, that's the ESP. Okay, so that's just VIN. I just want to know what it does. Seems like that's just flat out a 5 volts output, which makes sense. Then this ground, so 1, 2, 3, 4, 5, 6 up. 1, 2, 3, 4, 5, 6. So I'm guessing that's customizable. I really wish I knew. No? Is that just a ground? Sure, whatever. Okay, so... yeah, so... oh my god. No, that's just taking me to the... that just seems like that's a ground. So what is this relay doing? If that's just getting ground and power all the time, this is just effectively normally closed. Yeah, I don't know what they're trying to do here, because effectively this relay isn't going to be relaying anything. It's just closing this circuit over here. So this connection is absolutely fucking useless, I think. Okay, SRD5. Relay. Okay, data sheet. Function. Yeah, I don't know what this in does. Like plus to plus, and then that's common to in, and ground, and then in goes out to P13 controller. Like, I don't yeah, I don't know what that's doing. Of course. So we were already here, and this doesn't really explain what the in pin is. Or maybe it does. 1, 2, 3, 4, 5. No, it really doesn't. That's just showing 5. So what the fuck is in on that board, or on that relay? mean, it's wired up on my other one. Okay. What's this? Okay. Signal. Module has 3 high voltage terminals, okay, which connect to the device under control. The other side has 3 low input voltage pins, ground, VCC, and signal, which connects to the Arduino. Okay. AC or DC minus. Signal carries the trigger signal from the Arduino that activates the relay. Okay, inside the relay is a 120-240 volt switch that's connected to an electromagnet. When the relay receives a high signal at the signal pin, the electromagnet becomes charged and moves the contact of the switch open or closed. Interesting. There are 2 different types of electrical contacts inside, normally open and normally closed. When you use will depend on whether you want the 5-volt signal to turn the switch on or turn the switch off. The 120 is usually the common terminal in both configurations. Use the normally open contacts, use the anode contacts. Still not entirely clear why we would need this signal wire, but apparently we do. Okay, so if we go back and look at the schematics, so since it's high, it's looking for a +5 to turn this on. So looking at this, we are connecting DC plus to both and then effectively just jumping this over to the signal. So this relay right here will always be on. The right one for P12 controller pull X driver will just always be on. So I don't understand why the other drivers don't have this, but this one does, especially since this is just always gonna be closed and completing the circuit. It makes no sense at all. It's almost like, hey, we bought 2 relays, we need to use 2 relays. I really don't understand this, especially considering in the V1 configuration we don't have that same thing. The pull X driver is just direct onto the controller, I'm willing to bet. Well, it has to be. There's only 1 relay in the original. Yeah, so if you look in the, if you go back and look in the control panel, there is only 1 relay, and that's to turn the torch on and off. So, flat out, I have no idea what the fuck this relay is for. It makes no sense at all to me. So we're just going to remove this relay and we're going to go back to the way it was configured before. Obviously I'm not doing this opt ISO bank crap. That's W108 going to the 5-volt bus somewhere. If using USB connection to cell phone, if using USB connection to cell phone charger is not required. Right, yeah, I'm going to be USB connection. I'm just going to plug a cable direct in, although the connection on the new ESP is micro USB, whereas the old one was USB-B, I think. Anyways, we're going to need another long cable. Not a big deal. Okay. So really all I'm changing and care about is controller wiring here. Don't care about any of this. dir minus Z driver, dir plus Z driver, pull minus Z driver. Yeah, okay. This wiring should be fairly straightforward. So I'll leave this up on the laptop, but we'll jump back over to the other camera to start swapping this wiring over. All right, so I actually emailed JD's Garage, and they emailed me back super duper quick. I was quite impressed with how fast they emailed me back. So for this, I will be using their supplied voltage divider, and that's this guy right in here. So I'll have the raw voltage come into 1, the raw voltage ground come into 2, and then 3 and 4 go into the THC. So nothing, crazy there. But then what I will have is, so 1 and 2 is the arc on signal for your plasma cutter. If using the Lotos LTP, whatever. I didn't understand at first what the arc on signal meant, because this says the torch relay that starts the torch is wired exactly the same with or without the torch height controller. Leave this as it was prior to you installing the torch height controller. No wires from the relay are connected to the torch height controller. So I didn't realize that arc on was slightly different than the arc on from the relay. But after reading the manual for the prime weld cut 60D, I have this pin 9 and 10, and it says pin 9 and 10 gives the OK to move signal. These are dry, normally open style contacts. It is non-electronic switches that close when the pilot arc transfers to cutting arc, sometimes referred to as arc OK. I'm guessing that arc on and arc OK are the same thing, and this is what I need to connect to. So I need to run 4 more wires into the box from the CNC plasma cutter. So in this case, I'm going to use the raw voltage, which is what? Pin 5 for positive, pin 7 for negative. So yeah, I'm going to use pin 5 for positive, pin 7 for negative, and then I'll configure that in the THC adequately or accordingly. And we will... Yeah, so I will start getting some of the placement and some of the wiring figured out. So let's transfer over to the other camera. All right, so as I just mentioned, I need 4 more wires coming into this box. So I'm gonna run a red and a black for my voltage, and then I'll run yellow for the arc OK or arc on signal. So these are the 2 wires coming in already, and they go to this connector that plugs into the back of my CNC. As you can kind of see, I've already got 2 wires on it. So I will just have to read the manual, and then I will have to pin appropriately for the rest. But let's start by getting this wire run.
So looking at our connector, 9 and 10 are kind of on the outside, and that's okay to move. But my raw arc voltage is 5 and 7, which is, well, it's up here, but 7's kind of in the middle. So I think I'll probably do 5 and 7 first, and then I'll come to 9 and 10, which are on the outside. That'll probably make this the easiest. So 5 is going to be my red, 7 is going to be my black, 9 can be white or yellow, it doesn't matter, and then that 10 can be white or yellow, it doesn't matter. Alright, so the way these connectors go together is actually really simple. And obviously I have all the wires loose still, so I can still feed them back as needed. But we're just going to pull all of this stuff back. What I really should do is just tape up the end of this real quick. I don't think I have any tape out here, so I'll go grab some. What in the hell did I do? This is a whole mess of wires, and I fucked this all up. I mean, I can fix it. It's not a big deal. But now, what I need to decide is where I'm going to put stuff. So I said I need to run all these wires to the inside. That may not be the case because I need wires going off of here to the voltage divider, then out of the voltage divider back up into the JDs Garage THC. And I think I want the THC. Let's just pull this out so I'm not throwing it around and breaking it or anything. I think I want to have the THC mounted on the top, right? Or at least like playable out here. I can move it around, do some shit like that, something like that. And the reason why I think I want that is because I need to adjust settings and play with it, and what I might want to do is just pull this away and work on it. So I think that's what I'm going to run with. So the two wires, the yellow and the white, will need to come to the THC, which is going to be kind of loose and free. The other two will have to go in because I'll mount the voltage divider, which is, I think I dropped it, this guy here. So this I will bring inside, wire in. I'll also use some Velcro to stick it to the side. And then I'll need two wires coming back up and out into the torch height controller. Yes, 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 yes. So. Okay, so what I'm going to do is I'm going to pull the tray out of here. Oh, Yeah, I guess I could. Just undo that, and then all that'll just pop right out. So yeah, obviously I need to do some more wiring. What's the best way to do this? I don't really want to wire it with it on here because I need to do some more zip ties. So yeah, I think I got to pull this out. I know I said just because I'm getting zip ties doesn't mean I have to replace anything, but I have chosen to replace everything. Now, the reason for that is I do have this here box of new wires, a lot of them even, and I will be able to cut these down to the correct length to wire into the controllers. Now, if I was smart, I did this X, Y, and Z. But of course, I don't have anything labeled in here because I am an idiot. So what I can do is I can look at the dip switches in here, and I can look at the old wiring diagrams for the original V1 of this, and then just make sure, if I was smart, I wouldn't have pulled all of this shit out of the controller, out of the older controller. I would have actually, you know, done it one by one, and then I could have been like, oh, this goes to this, this goes to this, this goes to this, but I'm an idiot, and I didn't do that, so now I gotta do a little bit more work to figure out what all this is. But in the interest of time, let's just cut all these zip ties. That one too. Yeah, I think that one too. tell you, there is always something. So when I'm looking at this controller, I've got VIN, ground, D13, D12, D14, and all of those are represented up here as well, right? VIN, ground, D13, D12, D14, 27, all the way up to, I got another VIN, VP, EN, and then, you know, on the other side we've got all of this, down to ground 3v3. So now I'm just going to quickly show you our documentation. Apparently we're supposed to have 5 volt down here, ground, what's that, like an S03, S02, P13 ground, P12, P14, P27, P26, P25. As you can see, this appears to be a different controller, despite the fact that the graphic here shows ESP32-WR000M-32D, ESPRESSIP, something like that. And if we go back here, okay, ESP32-WROM-32D, but it's completely different. So now we'll go on the computer and figure out what's what, I guess.
Okay, so this is what I bought. I bought the ESP 32, do it, you know, ESP room 32 board, USB-C, wireless LAN, Wi-Fi, all that good stuff. 30 pins. So I came over to the parts list. ESP32 microcontroller needs to be 38 pin version, not 30 pin. Check controller chip before buying. It will say ESP room 32 on chip. Well, mine says that, so this isn't entirely accurate. And then Amazon link changes on a regular basis. So I need a ESP32 38 pin controller. Looks like this guy right here will do me. Let's just see what the pinout says. There we go. That pinout looks about right for what I expect. Well, I'll buy that now, I guess. And so the thing is, I already have that little green breakout board for the 38 pin connector because I bought that incorrectly the first time around. And clearly I need the 38 pin version, so there we go. Oh, I should probably double check. Does this say ESP32 room? It does. So yep. Just a word of warning, make sure you verify your parts, and you know, if it specifically says you need the 38 pin, not the 30 pin, make sure you don't buy the 30 pin and be an idiot like me. Otherwise you're gonna end up buying twice. So yeah, now I get to stop on this project and wait until that comes in on Friday.
Yeah, let me be clear, this fuck up was entirely my fault. This had absolutely nothing to do with JD's Garage. They very clearly and accurately called out that you need the 38 pin, not the 30 pin. I just apparently cannot read. So that's fine. I'm not worried about that. And again, no fault on JD's Garage, because that is not their fault that I can't read. And yeah, as I mentioned before, I had fucked up and bought this board, which is for the 38 pin, but I bought the 30 pin controller. So I made a series of fuck ups in my purchasing. Can't even claim that I was drunk, because I don't drink anymore. Alright, since I'm waiting to hear back from JD's Garage, I'm just going to, let's just connect this, get some power to it, and I just want to verify a few things. So, got ground, this should be 5 volt. 1.5 volt, that don't make no sense. Maybe because it's not programmed? What the hell is going on here? Ground, 5 volt. Yeah, okay. Now that's 5 volt. Oh, that's because that's not ground. That's C and D. Okay, yeah, ground is up here. 1, 2, 3, 4, 5, 6. Is that 5 volt now? Yeah, okay, so that's 5 volt. That's 3.3 volt. So yeah, I really do not know why 3.3 volt is going out to the drivers when they want 5 volt. So I emailed JD's Garage, I'm waiting to hear back, but I am not gonna wait for them to email me back. I'm just going to wire this up like we had in V1. So 5 volt is gonna go to the DC plus, and then that 5 volt is gonna jump up to all of our drivers. And yeah, that's what we're gonna do, because I don't believe that. I just don't believe that we want 3.3 volts going out to the drivers. That's going to underpower them, maybe not trigger them correctly, probably cause a ton of issues. So we are going to fix that. So I'm going to quickly show you something here that always makes me, kind of question everything that's going on. So we've got the torch height controller schematics here. Now this is a backwards 1, a backwards 2, a backwards 3, and a backwards 4. To the voltage port on your plasma cutter, red is positive and black is negative. So this says 1. And to me, this is kind of how I'm looking at it, right? Because I've got the 2 ports for screwing the terminals down, which kind of representative of here. But if we go like this, I don't know how well you can see that. This is 2, this is 1. So going based on the schematic and how this is kind of laid out on the schematic, if I were to plug 1 into here and 2 into here, this is just backwards and wrong and gonna break shit. And same thing on the other side, right? So 4 is on the bottom on the schematic, but 4 is on the top here. 3 is on the bottom, 3 is on the top. So just a word of warning, make sure you are reading the schematics and the diagrams and making sure you're paying very close attention. Seeing the backwards one is kind of a dead giveaway. I'm guessing this was originally flipped like that, which would kind of make sense, which would make 1 on the top, 2 on the bottom, 3 on the top, 4 on the bottom. So in whatever software they designed this piece on, it was originally designed where this was flipped, and all they did is they just flipped to this image to get it so that the schematic would line up nicely, instead of having the wires come up here and over here and then have this just kind of go up and left to the plasma cutter. So instead we get a potentially horrendous situation, because if we're just like, okay, right into the top, well, that would be wrong. So yeah, just make sure you're paying close attention to the schematics. And also, had I pulled my head out of my ass earlier, the torch height controller, I'm not going to show the schematics for it because, you know, that's JD's Garage. If you want to see all the schematics, pay for it. But the torch height controller actually goes into the Z motor. So I need to redo some of that wiring. I'm not too concerned about that though. But yeah, so I'm just going to continue on wiring this thing.
right, so I just got the box all wired, got it all connected back up, did a quick little test just to make sure that the orange pins for the 3 controllers are still talking to the right pins. Everything seems to be okay there. So now it's time to get the software loaded onto this new ESP32. And that's all done through the open build software. So we will run through that. So I have the instructions up in the Chrome window. I'm not going to show that just because I don't want to give away too much of JD's Garage's secret sauce. Okay, so I got everything connected. You just saw the open builds. It's got that COM5 Silicon Labs USB to UART, which is what I need. Okay, so I need to figure out which software I'm going to go with. I'm just going with the wireless software. I'll probably always plug this thing in, so I don't really care. Okay, firmware flashing tool. So yes. Last you malfunctioned and does not recognize it. Interesting. Might need to install the drivers. Let's just see here. It's going to be Black Box X32 machine style custom firmware. Flash firmware resettings. GRBL settings backup. Okay, don't need the GRBL. Okay, download. Wi-Fi firmware open. Yeah, it's just going on the controller. Let's flash. Let's see what happens. Boot mode detected. Boot. Okay, so that chip needs to be in download mode. Okay, so there is information on this error in the instructions. Let's see here. If your form flash, it could be that your computer is unable to put the controller into boot mode. To force the controller into bootloader mode, press and hold the boot button, then press the reset button while still holding the boot button. Let go of reset and wait 2 seconds. Okay, so let's boot. So press and hold boot, then press reset. Hold the boot button, then press the reset button while still holding down the boot button. Let go of reset and wait 2 seconds, then let go of boot button. Do this procedure after you start the firmware flash. So I think that's probably gonna fail again. Yeah, okay. So I think I need to go for my flashing tool. Yeah, that's the right just firmware. Oh, do I need to connect to it? No. Nope. Fuck. Okay. I guess let's figure this out. Alright, so I just figured I would reinstall the OpenBuilds driver software. Maybe that was playing into this. I guess let's just try this again. Everything's plugged in. There we go. Yeah. Firmware. No, looks like that did fuck all. God damn it. Suppose the next thing to try is I do have a second controller, so I USB device not recognized. Yeah, okay. Okay, I'm gonna go grab my other device, I guess. Alright, so fortunately these things come in a pack of 2. So this is the second one. I'm just gonna use a different cable real quick here. And we'll just see if I can get this one flashed up. Interesting. This one, when I plug it in, I get just a solid red light. So let's just real quickly test this. Sure. Hey, look at that. It's flashing. Okay. So that's interesting. So I wonder if something's happening where one of the connections on the board that's in the enclosure is fucked or something like that. Okay, so that's done. Press the reset button, which is this guy. Should reboot it with the new firmware. Okay, well, in any case, just unplug it. Okay. Let's see, can I connect to it? Response from controller. Okay, so I can connect to it. I mean, I'm sure all the GRBL settings are wrong. So that's okay. Now I need to figure out why that other one doesn't work. Oh, ESP32 LED lights. Onboard LED. So when I plug the actual controller in the enclosure in, I get a red light and a blue light, which is odd. So yeah, I get a solid red and solid blue. Don't know why. Let's see if we can troubleshoot and figure this out.
Alrighty, so here we are looking at the controller. I'm just going to plug this in. So yeah, so you can see we got solid blue, solid red. And if I try flashing this, just some firmware, flash, we just get nothing. So it connects, but we get nothing. So one thing that we did is I took the 5 volt to power the DC relay, as well as power all of the drivers, right? So now we got red with flashing blue. I don't know if that's any better. But let's press and hold boot and then reset this. Okay, so now that we have pressed and held the boot button, which is this guy here, and then reset it, we just got a solid red. So I think I'm going to be able to flash this now. But let's try firmware flashing tool, custom, firmware that, yep, flash. No. Still did not work. Okay. I don't know why that did not work. Let's see here. No. I don't really want to plug that in just anywhere, but so why are those two kind of flashing in line, right? That's the +5 powering that. That's the ground. I don't care too much about the ground, but then this brown one here is the inputs trigger. So if I unplug that, why does that still? Kind of odd that that LED and that LED are flashing, because the only thing connected to this still is the ground. So I guess with the ground unplugged, 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. Yeah. I guess let's see if we can flash this thing. Nope. Still no flashy. Okay, let's try this then. Let's unplug that cable. Let's use the same cable that I used to flash the other one, just in case that's the issue. Okay. Okay, that's working. That is working. So it could be that this is not a data cable. Isn't that interesting? Okay, so that's okay. I can live with that. Okay, so firmware completed, that's fine. Okay, so let's unplug this guy. Actually, I'm gonna leave that plugged in. I'm going to unplug that from the laptop. We're gonna plug this in down here, and I'm gonna plug this USB hub and this big cable back in and see if I can't flash it again. Okay, open builds, wizards, firmware flashing, custom, flash. No, that does not work either. Interesting. Oh, of course that's not gonna work. No, that should work. Okay. So is that hub just junk then? At least for flashing? I can't really think of what else it could be. Could be this massive extension cable is crap. I do have another one here. Let's try this. Okay. We'll try and flash this again with the custom firmware. Nope, that ain't working. So maybe that hub is junk. That would be unfortunate. At least for maybe it's just junk for flashing. Okay, let's just try plugging this directly back into the laptop. Nope, that ain't working either. Okay. So then, oh, no, it is working. It took a little bit, but it did detect it, and it's currently flashing it. Okay, so what the hell? I wrote it, yep, okay. It's saying it's good, it's happy. The only thing I can think of is I have run into issues with USB things on this piece of shit Windows 11 laptop. You know what I'm gonna do? Let's just unplug this. Let's do this. Let's plug this guy back in. Let's plug those two back in. Ground P13 5-volt. Let's just see, can I connect to it? So Windows just blue screened on me as I fucking tried to connect to the comm device. Man, this combination of Alienware / Windows 11 is just absolute junkety junk. Alright, gonna stop recording for a second here. Alright, let's get open builds. It detects the device. Let's see if I can connect to it. No, it is not liking that. So let's see if I unplug that 5-volt. Yeah, okay, so it does not like 5-volt going to the relay and going to all of the drivers. So I'm guessing I am going to have to run the 3-volt up to all the drivers. It doesn't make a lot of sense to me, but that is the way they have spec'd it out. So we're gonna do a little bit of rewiring and just test it at least. Kind of hard to get this set up to see everything, but okay, let's see here. Let's just okay. So the controller seems to be working all right now. It's not got that solid blue anymore. Maybe that solid blue means overcurrent on the 5-volt side. Don't know. Let's just see, can I connect to it? No, cannot connect to it. Is this cable just a pile of junk? How about now? Can I connect to it? No. Okay, if I pull out the 3v3, John denied for some reason. Okay, so that connected just fine. Let's disconnect. Let's plug 3v3 back in. Connect. Connect works. God, I hate Windows 11. Let's unplug that. Everything's disconnected. Let's plug this back in. So again, we just got the single red on the controller. I mean, the relay seems to be doing its thing. Cannot connect. COM port access denied. Oh, Windows 11. What an absolute pile of fucking trash. I'm about to get my Windows 10 laptop. Alright, we're all rebooted up. Let's see if this works. Log connect, log serial console, connect. Nope. Does not like it. Unplug 3v3. Connects just fine. Oh my god. What the fuck is going on? Maybe the USB power just is not enough for this thing. Okay, let's just quickly check some stuff. Okay. So I'm just going to unplug X and Y, see what happens. Okay, I can connect with X and Y disconnected. Let's reconnect Y, I suppose. I can still connect. Is that with the three? Yeah, okay. So is there something with X that's all fucky? I don't know. Let's plug X back in. Can I connect? Now I can connect. What the fuck? What is going on? Whoa. Okay. Now I can't connect again. Okay, so let's unplug Y, I guess. Cannot connect. Let's unplug X, I guess. I can connect. Let's plug X in. I can connect. Let's plug Y in. I can connect. What the fuck is going on? It seems like if I try and connect on a fresh boot with all of the controllers connected, it just can't connect, I guess. Oh man, that's frustrating. Yeah. Oh man. And I'm guessing there's something in this ISO bank crap. Because right now if I try and move anything, it says, let's connect, and then it says, please wait for machine to be idle. I need to get the GRBL loaded in anyways. This is frustrating as shit.
Alrighty, so we are back on the schematics because as I started wiring this, I saw that we've got the 3.3 volt pin going to the DIR plus Z driver. But if I look at the driver, we have 3 volt 3 controller coming into pin number 1, 2, 3, 4, which is 1, 2, 3, 4 DIR plus 5 volt. So why are we running the 3.3 volt pin output of the ESP to the 5 volt input or signal and jumping that to the pole plus, which is also the 5 volt signal? Like we're undervolting the signals for the motor. That doesn't make sense to me. So I'm going to email them about that. I'm also going to email them about that second relay that they have wired up, and I need to figure out for the Z limit switch, because I'm not running the opto isolator bank. I just want to wire the Z probe directly into my controller, which looks like it's going to be P22 on the controller, but I just need to figure out if that's how that's actually going to work. So a lot of questions upgrading from V1 to V2, a lot of things that don't really make a ton of sense to me. So yeah, I'm yet again dead in the water while I email JD's Garage. And to be fair, on the V1 version, I had the 5-volt output. It jumped the relay, or it powered the relay, and then it jumped up to each of the controllers. So I was getting 5-volt output to power the relay and the controllers, which makes sense to me. So anyways, I'm gonna pause here until I get an email back.
All right, so I think I figured out why they have the second relay for the XDIR or pull minus, whatever it is. So if we just, it's down, we plug it in, we try and connect to it. It kind of freezes for a few seconds, and then it goes into this like cycling, trying to connect to the controller, and it doesn't work. As soon as we unplug X, we can connect. We can plug X back in. We can disconnect. We can connect. Disconnect. So if we unplug this, in theory, if I unplug the secondary X connector, if I plug this back in, I should, in theory, be able to connect. Which I can. So what does that tell us? Well, that tells us that something is happening when everything powers up and overloads the controller. Now, since this is custom firmware that's loaded in, I'm going to hazard a guess, and I'll confirm this with the multimeter, but I am willing to bet that the 12-volt output is set to a delay or something where it'll take a few seconds before it actually initializes that 5-volt output, which gives the controller time to start up. Everything will kind of do its thing, and then the 5-volt or the 12-volt will initialize the relay and then connect to the DirX. Because it seems like the pull minus. Because it seems like having pull minus connected at startup is the problem. So let's do that. Let's just disconnect this. And I would like to get a couple of clips on voltage and ground just to see, after we plug it in, how long it takes for us to get voltage. So let's just disconnect that. I'll grab a couple of clips and we'll get set up here. So fortunately I got a ton of these just offcuts kicking around on the ground. So I'll throw this into the voltage output, and then do I have another ground kicking around? Yeah. Let's see here. One, two, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so red should be plus 12. And brown should be ground. So I just want to see, after I plug this in, how long it takes for the voltage output to register. Stopwatch, okay, so start. I should have plugged into the wrong place. That's weird, I don't have any voltage output. Is that plugged into the wrong place? No. What's going on here? Why do I not have 5 volt there? Well, that's really odd. Okay. Okay, so apparently that ground doesn't work for some reason, but the top one does. So let's just use that. Okay. 5 volt, 5 volt. Okay, let's try this again. Stopwatch. And no, it was instant. So unless like the delay of the relay starting up is enough to let the controller fire up, that's kind of the only thing I can think of, because yeah, that was like the second this is plugged in, I'm you know, it's starting to get voltage. So I guess in that case, let's see how long it takes that relay to energize. Okay, let's pull that out. I don't want to create a short. Let's pull that out. So I'll tell you, with how fast it gets voltage, like this relay in theory should get voltage like, you know, just as fast. But maybe that split second where it's flipping from normally open to normally closed is enough for this to work. Let's grab that other relay, I guess, and let's see. But effectively, this just feels like a really big hack to have this relay doing this. Like, it almost seems like, you know, firing up all three of the injectors at the same time. Like, I don't know anything about these electronics, so I don't know what pull minus or like, I don't know what the pull minus does, or pull positive. Like, I don't know what it does, so I can't really say like why this is a hack. I mean, obviously it's a hack that works. I know it's a hack if I prove that this does work. We'll certainly know that it is a hack. Okay. All I want to do right now is I just want to test and figure out how long it takes for that relay to flip. Because, I mean, everything's powering up pretty quickly, so I think what's going to happen is it's going to power up and flip almost instantly, but just that millisecond is enough for the controller to start up properly. What did I do with those? It doesn't matter. Got my multimeter set to continuity. I need these. I don't need these, but I want these. So I'm willing to bet it's going to be like 1 or 2 seconds after I plug the controller in for this to close. And we'll hear it on the multimeter when this energizes. Okay. Not even a second. Just a fucking like 0.28, not even, I can't even hit it fast enough. Like it's just, it instantly flips. But I believe that instant flip will be just enough to get this controller to start up. So this is just a hacky situation. Like, this is not needed, right? Because as you can see, all this is doing is, as soon as this starts up with this wired positive here, jumped to the input signal, as this just closes the relay immediately. So next test is we are going to undo this stuff, and we're just going to wire this up outside the box, and let's just see exactly what happens. Okay, let's see what we see, I guess. Alright, detected. Just give it a few seconds to power everything up. I can connect. Wow. Wow. That's something else. Unfortunately, I don't know the full details of the micro drivers and this ESP32 board. Obviously on the Arduino we didn't need to do this. So there is just something wacky going on here. That when you power up the ESP32, if pull minus on the X driver is connected, that it just doesn't work. And the next thing I got to figure out is, this is telling me that to wait for the machine to be idle before trying to jog, but that could be because if I go into troubleshooting, the X limit and the Y limits are triggered. The door sensor is open. Yeah, so there are some wacky things going on here still that I got to figure out. I do not like this. I think this is just hacky bullshit. But again, I don't know the technical reasons for it. I have asked JD's Garage in an email why we need the second relay, so I'm hoping I get a technical answer. But yeah, I guess I will wire that in kind of permanently in a better way. Yeah. And it's only the X driver, which is odd. Although I guess the Z driver, its dip switches are different, I believe. So that might have something to do with it. Yeah. Let's get the second relay wired in.
Alrighty, so I have been doing a lot of research on this, and what I found out is that if we look, we are using P12 to go to COM Relay 2 for X driver pulse minus. And if we look at the ESP32 pinout right here, you know, that's the one right above ground. That's GIOP 12. And if we look at the pinout, GPIO 12 must be low during boot with a big exclamation mark. Pay close attention because its behavior, particularly during boot, can be unpredictable. Use them only when necessary. So what does that mean? Must be low during boot. You got low, 0 volt, high, 3.3 or 5 volt or whatever. So if at any point in time, GPIO 12, which is pin, whatever that is, 13, I think it is, right? Yeah, pin 13. If this is ever more than 0 volts during boot, you're going to have problems. So that's what's going out to, and this is just during boot. Keep in mind, that's just during boot up. Anytime after, it's fine. So what we've established is we have that relay. It's going to take a microsecond for it to flip from normally open to closing the circuit, which I believe will give enough time for the controller to boot. And then let's take a look and let's just see what GPIO 12 or what our pull minus shows during boot up, because that's what's really going to be interesting about this. If when I plug the controller in, if that shows anything more than 0 volts, well, that's potentially going to cause this problem, which is why we need the relay, which is why this is this big hack going on. And so I believe that we could now I can't because I don't have access to the original programming of this. I just have JD's Garage's firmware that they've provided. But I believe if they switch that pin from pin 12 to a different pin that does, inputs and outputs, we wouldn't run into this issue, as shown by the fact that the Y driver and the Z driver, their pulse signals don't cause issues. It's only the X driver, because X is on pin 12, which must be low during boot. So I'm going to swap us back over to the other camera. We're going to get the multimeter set up on that pin. We're going to fire this up and we're just going to see what happens.
Okay, so if you remember our setup from yesterday, well, it's yesterday for me, it's probably just a previous video for me. I've got 5 volts coming into this relay. Relay has jumped, and then I've got ground going into this relay. So what I want to do is I want to get my probe, my voltage probe on ground, and I want to get it on this relay, which you cannot quite see. So ground is here, GPIO 12 or X pull minus comes into common. So what I want to do is I want to check ground and common for voltage while this thing boots up. And I want to see if this has voltage as soon as I plug this thing in. So I know you can't see me plugging it in. It's more important that you see the relay and this. So let's see what happens. Yeah, so as soon as I plug it in, you can see that the voltage spiked, went up to like, what, 2? So that would technically be high during boot, and that's probably what causes this thing not to boot. And now it's sitting at 2.2 volt. So the fact that as soon as I plug this thing in, voltage spikes up, that's probably causing the problem. So I believe if JD's Garage reprograms their firmware so that we're using one of the unused I/O pins for pull or for X drive or pulse minus, we don't need the second relay. I'm still waiting to hear back from them. I messaged them yesterday morning. The first time I emailed them, they were really quick to respond, which I was very happy with. This time, I mean, they're who knows, right? They probably got stuff going on in their lives. It's spring, it's our summer, so I'm still waiting to hear back. If I don't hear anything back by tomorrow, I'll probably follow up with them and be like, hey, what's going on? I've noticed all these things during my troubleshooting, especially the GPIO 12 bits. But for the moment, what I'll do is I'll just kind of leave all of this shit hacked together in here just so we can maybe get some movement.
Alrighty, so in order to update the GRBL settings on the controller, what we need to do is in the background here, have I already downloaded the GRBL? I think I have, but maybe I haven't. I'll just need to make sure I downloaded the the GRBL settings, which is going to be electronics and software, supporting documents. Yeah, GRBL set backup settings.txt. So we'll just quickly download that. So what I had to do is on the controller, I had to jump P16 to ground, and that bypasses the E-stop, which I'm just going to leave permanently bypassed because I don't give a shit about the E-stop on my Plasma. This is like a home unit that only I'm using. I don't need fancy shit like the limit switches or the E-stop. So anyways, I got that downloaded, so I'm going to connect to the controller. When it connects to the controller, we get this GRBL howl settings, so we can restore backup file, downloads. Oh, looks like I already downloaded it yesterday, but whatever, that's fine. So we do that, and then we are going to save to firmware. Okay. Yeah, let's restart the controller. Connect. This thing seems to boogie. Look how fast that thing is moving now. Yeah, that thing seems like it's gonna be fucking moving this plasma cutter around. Okay, so I guess what I want to do is I just want to throw this back on the table, back under the table, and just see if it moves around at all. Obviously, knowing that my plasma is currently broken, I gotta 3D print a couple more parts to fully get it fixed, but yeah, this seems a lot better. So let's just see what we see. So I've been emailing back and forth with JD's Garage about a couple of things. One of them being this relay and the X driver pulse minus. And, you know, I explained to them what I explained to you is that GPIO 12 needs to be low on boot. I think this is what's causing the issues. And, you know, if they just flip it up to different pin P33, it should solve all the issues and then we wouldn't need that relay. And the response of, yes, that is possible, but our average customer has difficulties just getting the firmware installed, so we figured a mechanical solution would be better suited for our customer base. I do not like this answer because I don't understand the logic in it. So instead of having pull minus come off of P33 on the controller going directly into the stepper motor driver, so single wire up, you have that single wire going into the relay common, and then you have another wire coming out of normally open going up to pull minus, and then you also have to jump voltage from the controller into the relay board positive, jump that over into the signal, and then also ground the relay. So you're adding a whole pile of wiring instead of just going into the firmware and going, oh hey, this pin is now, instead of pin 13, it's now pin like 14. I don't think the programming should be all that difficult to change, and so I don't understand why this is the response, but it is what it is. I mean, it works as it's wired. and it works as the schematics show. So if you're just following along the plans, and you have to follow along the plans, if you like me wonder why this is the way it is, well, it's because of the specific pinout of the controller and the way it's been set up. So that being said, I broke the lower part of the Z-axis, so I'm going to quickly fix that. I'll fix that on camera, what the hell. I'll just time-lapse it. But yeah, I'll fix that, and then we will get this box plugged back in, and we'll get it, trying to run a job. One of my existing jobs that I've already run. We'll just try to get it to run one of my existing jobs, and we'll see how it goes. But before we get to that, I do want to quickly acknowledge, I understand that the guys over at JDs Garage have probably put in, thousands of hours into this. So while I don't understand their response and their answer, I do appreciate the time that they have put into building this. I have not put in the thousands of hours to design this. I have not, put in the time and effort to build all the plans, to keep all of that updated, to do the second version, to do the torch height controller. So this isn't a rag on them at all. I just, in my brain, I like things to make sense, and I like to figure out why things aren't doing what they do. So if I had access to the source code for the firmware, I would absolutely try moving pull Y, but since I don't, there's nothing I can do there other than just live with what I've got. So again, not ragging on them. I'm just trying to give my opinion and viewpoint on the situation. That's it. I appreciate them responding to me as quickly as they have. Like, that is phenomenal. Customer service is awesome. So yeah.
Okay, so I've actually been doing a little bit of work on this, kind of off camera. I was just playing around with a few things, trying to get stuff to work. Main thing is all of my limit switches here. I've just connected them to 5 volt. So my limit switches always show as closed, so I don't care about any of that crap. So that's down here. The second thing I had to do was for the probe for the Z-axis, I had to flip the wires around on the switch from, it was previously normally open, but now it's normally closed. So that's the other thing I had to do. Other than that, I have just been playing around with it, moving it. This hacky relay is still here because I can't do anything about that. Yeah, I'm about to run a job though, so I'm just going to load it up on the computer, test run it. I've got it so it's doing the Z touch off routine, so I want to make sure that works. Along with some of that stuff, I'm also going to check the torch height with the settings as it is. So let's just get right into that. Yeah, this will be interesting to maybe get the open builds recording going while I'm doing this as well. Okay, so let's connect to that. Let's open my G code. My G code is going to be my coolant overflow bracket. Okay, so this thing's going to be 5 inches long by just over 2 inches tall. So first thing I'm going to do is, reconnect. Nope. Why is it not happy? Now it's happy, whatever. Okay, so first thing I'm going to do is I'm just going to come over. Yeah, here's fine. Set 0. Run job. So I think right now that's probably a little bit too low. I probably need to adjust the cut heights in the program, but because I think that's way lower than a 16th when it drops down, but we'll see. Let's go grab a 16th inch spacer. So that's my 1/16th inch spacer, so I'll just run this again. That's perfect. Yeah. So we're actually a little high there. It's kind of interesting how the rest of them were, I'd say, pretty good. This touch-off routine is working fucking awesome, because look, if I put the spacer under there, it drops down and cuts the 16th above, and it's doing everything the way it's supposed to do. Yeah, this is working like a hot damn. So I think what I'm gonna do is I'm actually gonna just fire the cutter up. Well, actually plug the cutter back in. I'll set the torch height controller to idle. That way it's not actually modifying the Z-axis as we cut. I just want to make sure that the part cuts out well enough. And we'll try this. Although I do vaguely recall that this torch is sitting at an angle like this. So what I need to do is I need to space out the bottom here, this guy a little bit, so that it pushes it out. I just don't know how much I need to space that. Whatever, for this part, I don't care. I'm just gonna cut it as is. So I'm just gonna pause this for a second while I kind of get stuff plugged in and set up. Okay, so we got the plasma cutter plugged in. We got the job kind of ready to go, and then I realized, why am I cutting this out just kind of in the middle of the sheet? So we'll just reset 0 on this. Strip this over, pick this up. Okay, so by looking at the 3D view, we know this is like 3 inches, so I'm just going to 3-inch jog this down. And then we know it's what, just over 5 inch, so let's go 1, 2, 3, 4, 5. We'll set 0 there. Let's just burn and see what happens. You know, I could unplug this real quick, actually. If I just unplug the plasma cutter, I can make sure, I can do a couple of things. Run the job here, make sure the space that I have laid out is correct, and I can also take a look in the inside here, make sure that that relay is turning on. Yeah, it is. So, but this will just, you know, allow me to make sure that everything is going to be where I need it to be. Yes, this looks like it's actually offset by like -1/2 inch, so I can go to 0, I can go X over 1 inch, reset 0, rerun. The fact that it's doing the touch-off routine for every hole, I actually kind of like that. You can set it in the sheet cam software so that it doesn't do that. You can set like a distance. So for these holes that are super close together, I could say like if it's within ½ inch, just probe once and then it'll only probe the once. Like right here, it doesn't really need to probe twice. It's all within the same area. Oh, I can easily go over another solid inch, I think. Maybe even 2. 2 inch. Did I fuck it up? I think I fucked this up because I moved over 2 inches from its final position. No, I didn't home it first. Although this is actually going to work out well. Let's just rerun one more time just to make sure. Something doesn't seem right here. I don't know why. For some reason it just doesn't seem like this is gonna fully cut everything out. Whatever, fuck it, run it. Something's fucked up in the drawing, I'll fix it. What? Well, what the fuck is it doing this shit for? What do you mean, like nothing's fucking triggered? I mean, it made the first hole, which is good, I guess. What? What the fuck? What the fuck? What the fuck? Not triggered, and that is triggered. So fucking tired of this fucking thing. Triggered. Why the fuck did the probe go triggered for all? Interesting. So for some reason the probe goes triggered. So fucking tired of this thing. wish I could be on the troubleshooting tab at the same time so I could see what the fuck's going on. Because it seems like for some reason when the machine's plugged in and the fucking thing's running, so why the fuck does this work? For fuck's sake. Like, why is it when I plug the plasma cutter in? This is probably why it's using that fucking opto board, is to isolate all of the fucking different shit. So fucking ridiculous. I fucking hate this thing. V1 was not this frustrating. V2 with the random relay, it's just, I'm thinking about fucking stripping it all out and going back to the Arduino, because I fucking hate this thing. The amount of bullshit, because I don't, now mind you, I didn't follow the plans, that's on me. I didn't follow the fucking plans because I don't want all this other extra stupid bullshit. Apparently it's fucking needed. Like you can see when I run this normally, the probe doesn't just randomly misfire as it's moving around. So why it does it when the plasma cutter is on, I don't know. Because the probe goes, I'm using the ground from the fucking arc on-off relay. Yeah, it does not make any fucking sense. But it's repeatable. Like, plug the plasma cutter back in, and we will do the exact same thing again. I'm not expecting anything different. Because it's initial touch off, triggered, good, moves, and the probe fucking triggers for some reason. Like it takes a lot of force for this to trigger. Although, I mean, this is normally closed. Okay, you know what? Terminal's a little loosey-goosey. So let's just pull these off of here. We'll tighten these ends down a little bit. Okay. So those are much more solidly on the switch now. They were a little loosey-goosey before, so like I could wiggle the end and it would, so that may be enough to have just opened the circuit while it was running with the plasma cutter. I don't know why that would make a difference, but fuck, here we are. Let's run this again, I guess. What the fuck? Like, it's even worse now. Maybe the switch is just internally broken? Because we do it with the plasma cutter unplugged. So obviously I'm thinking this is something probably in the torch height controller, because with that unplugged, that means that my plasma cutter isn't sending raw voltage, it is not sending the arc OK signals. Oh, fuck. But the THC is just set to idle. So why the fuck does the Z limit switch appear to trigger, or the probe switch appear to trigger with it plugged in? It makes no fucking sense at all. Like, unless the torch height controller is sending some sort of back feed through the Z, but no, that doesn't even make sense, because the Z limit switch is entirely isolated. I'm picking up ground off of the ground for the torch on relay. That comes out to the limit switch. The limit switch feeds back directly into the microcontroller. What is going on? If I pull this off, in theory, that should trigger the probe. Yeah. Fucking motor's hot. Okay. I just want to see, like. So, I mean, to be fair, this limit switch is kind of loose right now, but I can wiggle this around, and the troubleshooting is not showing me triggered. So what the fuck is going on while the plasma cutter is plugged in? Like, it makes no fucking sense at all. First cut. It makes no sense. It makes absolutely no fucking sense whatsoever. Like, is the ground somehow pulsing on the controller when it's moving the Z? Like, that's the only thing that could possibly explain it. With the plasma cutter plugged in, the torch height controller, you know, up and running, as it moves, for some reason, the ground drops out. Like that's the only explain, like that. I fucking hate this thing. Looking at this, why are all these holes on different planes? Sketchy. I just... I give up. I just fucking give up on this thing. So I've just gone through and edited the video, and so I figured I'd do a little bit of an outro. So this upgrade from V1 to V2 has been very frustrating for me. I don't want any of the limit switches. The Z probe switch issues, I don't think that's due to the upgrade. I think that's probably due to like some interference. So I have ordered some shielded wire to go right from the controller all the way through direct into the switch, and then hopefully that fixes the interference issue. I haven't had interference issues with the motors or anything else, and those are all grounded in the same way. So I was able to get a cut, and this is a bracket for coolant overflow tank on the car. This is the part that I was trying to cut out. What I ended up doing is redoing the programming without the touch-off routine, and just I just did in sheet cam just a regular GRBL with Z exit or post-processor. So this is how I've been doing all my cuts before. So it's a static height. So I set the height of the torch right at the top of the material, and then it goes up, moves over, and just sets the height and does anything. It doesn't do anything fancy. The torch height controller would technically work, but it doesn't do the touch-off routine on every hole. Would I upgrade from V1 to V2 again? No. I don't think it's worth it. It's a lot of hassle. A lot of rewiring, and you know, you gotta use that extra relay for X pole minus, which whatever. I mean, it's not the end of the world. I think it came in a 2-pack, but it's just, yeah, it wasn't needed. Also, one of the main driving factors for me was the torch height controller. That would work in V1 just the same as it does in V2. So going back, I would not do this again, but it is what it is. I went through it. Got some content for the channel. So if you know, you guys have any questions on my upgrade or just on V1, V2, whatever in general, I'm always happy to answer them. Leave a comment below and you know, I'll answer them for you. Also, if you want more content on like how I set up FreeCAD or how I export drawings or how I've set up sheet cam, how I've set up the different tools for the different thicknesses of metals, I can do that. You know, how to set up the post processor in sheet cam. If you have any questions on open builds or you want me to do anything more with the plasma cutter, let me know and I'm happy to do it. But that being said, that is all the time I have for this video. So as always, if you've stuck around this long, I'd like to thank you for viewing, and we'll see you in the next one. Oh, I just broke something. Shit. Ooh, that's not good. Okay, I'll have to fix that.